Alright, this is Math 2, Unit 12, Lesson 2, looking at vertex form. I've already posted up a little worksheet for the worksheet from the book, from worksheet K. But as in class, we're going to do something a little different here. In one of your first lessons, you talked a little bit about standard form and what that looks like when it comes to graphing quadratic equations. With a standard form, if you recall, you had the equation y equals ax squared plus bx plus c. And what we were doing with a standard form in the first lesson was we were finding what the vertex was going to be. And to do that, it was a process. We had to use the formula negative b over 2a. And actually, this was in lesson 2 that I did. Sorry about that. You would use this formula to take the value of b and a, and that would give you your x value. That x value would be your line of symmetry, okay, or your axis of symmetry for where the parabola would curve, at what point it would curve at, okay. Then we would take that x value and we would plug it back in order to find out our y value. Once we had the x and the y, then we would know what the vertex was going to be, and we would know what our maximum or our minimum values were going to look like. So it was a process to go from the standard form, use this equation to find out the x value or the axis of symmetry, plug that back in to find out what y was, and at that point get the point for what the vertex is going to be. With vertex form, we have the equation looks like this. We have y equals a times x minus h squared plus k. Vertex form, because it says vertex, is designed to give you the vertex in a much simpler fashion. The way it works is we take the h value here, and the h value becomes our x value, except one thing, it's the opposite. So if it's a negative, it becomes positive, positive becomes negative. So you get the opposite there, and the k value becomes our y, and so our vertex is simply x and h and k, which are really the new x and y. So that's the way the vertex form is set up. So it's a lot simpler because there's less algebra and work to do. You don't have to use an equation to solve for x, plug it back in and solve for y. You can simply look at the numbers that are there and to see what the vertex is going to be. And we're going to use that process now to answer these questions here. One thing I believe your teachers are going to want you to do is also list in each of these cases here, what is the vertex, what is the axis of symmetry, and I know in Mr. Lee's class he wants you to describe its shape, or line of symmetry, sorry, line of symmetry, and he wants you to describe its shape, whether it is wide or narrow, and that depends upon the leading coefficient here. So here we go. Let's look at this first one. Define the vertex. The vertex is going to be, again, this is my h value, so I take the opposite of that, which is negative 2, and I just take that value, which is negative 1, and that's my vertex. So it's a lot simpler than the way we did the first time. So my vertex will be negative 2, comma, negative 1. The line of symmetry is going to be at that x value, which is going to be at negative 2. It's going to be when x equals negative 2. So if I was to plot this so far, I'm going to be over at negative 2 and negative 1. That's my vertex point. Okay. My line of symmetry says that my parabola is going to curve around that line right there. Okay. My shape, because it's a whole number, when it's a larger whole number, it means it's going to be narrow. The domain will be all real numbers. That's going to be my domain there because it's a quadratic equation, no problem there. The range, though, okay, because this is a positive value, it tells me I'm going to be curving this up like so. Okay, I have a positive x squared there. So because it's positive, I'm going to be curving up, which means my range, what I want to find out is, this is my y, right? How is y going to work? Y is going to be from this point all the way up. So y will be any value greater than or equal to, what's this number? Negative 1. Again, if it's positive, it's greater than or equal to. If it's a negative, like you might have, don't have it in this front page here, it'd be less than or equal to. And then we just look at the y value of the vertex. The minimum occurs when x equals, well, the minimum value is here, when x equals negative 2. And the minimum value of the function, that's going to be the minimum y value essentially, is going to be at negative 1. Okay, these two things here should be written as max or minimum because it depends on what shape the graph is going to go. In this case, we're dealing with a minimum, so that's okay. All right, and that's what we're trying to do today with all these problems here. All right, let's take a look at another one here. Let's move down to number 3. Okay, when I look at number 3, again, my vertex, which teacher probably wants you to figure out the vertex here. My vertex is going to be at the opposite of that, which is positive 4, and whatever that is, negative 4. Okay, and that's what that one's going to look like there. Now, my and then my line of symmetry is going to be happening when x equals 4. It's the same value there. And for my shape, because I have a whole number in front, this would also be a narrow shape. So when I plot this here, I'm at 1, 2, 3, 4, and I'm down at negative 4. 1, 2, 3, 4, and that's where I am to start my vertex there. I know it has a positive value, so my shape is going to curve up like this. And those aren't the accurate points, I'm just sketching one out there. My domain, once again, will be all real numbers because it's just a quadratic equation, no problem there. My range, my range is going to be from here on up, right? So that's going to be y is going to be greater than equal to whatever this value is, which we said was negative 4, greater than equal to negative 4. My minimum occurs when x equals 1, 2, 3, 4, when x equals 4, and the minimum value of the function is also negative 4. So that's how that one works right there. Does that kind of make sense, I hope? So some basic things. Again, the vertex form is a lot easier. So it's nice to work with vertex form. It's a lot less work for you to have to mess with. Let me flip it over to the back side. Let's see if we can find a different one here. Let's look at number 5. Let's do that one here. Number 5, yeah, that'll work. Okay, so on this part here, I know that when I look at Mr. Lee's notes, the things he's asking you to do is to write down A, what is the vertex? On B, he wants to know the direction, which way it faces, up or down. C, he wants to know about the shape, is it wide or narrow? D, he's asking about the line of symmetry. E, he wants to know the relative maximum or minimum. F, he's wanting to know the value again of at what point it is going to be, sorry, just like this one here, the value of the function. And then he had G, the domain, which is x value, and H, the range. Those are all things he's looking at there. So when we look at number 5, let's take a look at that one here. My vertex, part 1, is going to be the opposite of that, so it's 3, comma, and that number 4. For my direction, I have a negative in the front here. Now that means there is a negative 1 as my coefficient right there. So there's a negative 1. Because it's a negative value, this shape is going to curve down like that. So I might just draw a shape, or I could write the word down. For my shape, because it is a whole number, this is just going to be a normal curve, nothing too fancy. If anything, it might be narrow because it is a whole number compared to what a fraction might look like. Again, that's just more of perception. D, my line of symmetry is my x value. So line of symmetry is going to be when x equals 3. That's where I will curve things out at. So I look over here, I have 1, 2, 3, and 1, 2, 3, 4. This is my point. My vertex point is x comma 4. Right, that's my vertex, and we know we're going to curve it, right? We're just going to curve this around like so. So my line of symmetry is right here. This is where the parabola can fold over and match in 2 parts. In this case, I'm going to have a maximum because of the way the shape goes. This is my maximum value, and my maximum is going to occur when y equals 4. So maximum occurs at 4, and my value, for that, would be when y is going to be less than or equal to 4. So it has a maximum. And then for G, my domain is all real numbers again. And for my y value, my range will be y is less than or equal to 4. So I guess this one probably could still just be 4. I'm not sure exactly what they're looking there. It's just, if you know, it's just the same numbers again and again. So once you find the vertex, you're just drawing that shape, sketching out to see what it looks like, and that's all that has to be done. So let's look at number 7 real quick. Number 7, same type of idea, okay? I take the opposite here and I have -3, comma, and there's my y value 4. That's my vertex. 1, 2, 3, 1, 2, 3, 4, and I plot that there, and there's my vertex value. That's A. For B, this shape here has a -2 in front, so we're going to also be curving down. All right, nothing fancy there, which means it'll have this kind of shape to it if I plot that out there. For C, we want to know what kind of shape it's going to be. Again, this is kind of a regular shape or a narrow shape because it's a whole number. All right, my line of symmetry is going to be right here at x equals -3. For E, this is going to have a maximum because it curves down. For F, the value of where that maximum happens at is going to be right here at 4. And then again, my domain, as always, is all real numbers. I shouldn't say always, but these lessons they are. And my range is going to be y is going to be less than or equal to, because we have to go less than that line, less than or equal to +4. All right? So I hope you get an idea there. The other ones are all the same kind of pattern. You look at number 9, again, vertex, opposite, and the same, so -2, 4. You can look over here, vertex, opposite, -2, -1. Vertex up here, number 8, opposite is 2, -2. And the vertex for 6, opposite, and the same 3, and the same -3. Go through the process, decide what's going to go. This is positive, so that since it's positive, we know we're going to be curving up. This one is also positive, so we're curving up. Over here, we're negative, so we're curving down. Over here we're positive, so we're curving up. And that's the basics, vertex and the curve, and that's what today's lesson is about. Okay, hope that helps. Have a great day.